Hello everyone, welcome to my channel Tech Tejendra. And in this video, we will talk about the green IT and the sustainability. What are these and why it is required in our IT sector and how we can implement in our IT sector. So let me go ahead. So these are the point of discussion we will cover in this video. What is green IT sustainability? What are the green IT aims and the goals we need to achieve? Then we will, because it's a very important topic and related to the environment. So we also see some very important quotes from the leaders and from the experts. Then in the next phase, we will narrow down our discussion, okay, and we will see the ways to implement these green IT in the IT sectors, in our applications, in our organizations. Why we require serverless, we will again a little bit narrow down, okay, towards the serverless technology. Then we'll understand serverless and the container runtime. We will see some case studies, some architectures, right? How we can implement these serverless in our monolithic applications, how we can implement the function as a service, right? And in our DevOps pipeline, build pipeline also, if we can, how we can implement the serverless. So, okay, so what is green IT and the sustainability, right? So once we start talking about the global warming, the greenhouse affected, and the climate change, right? So few organizations, few sectors come in our mind, right? One is manufacturing sector, energy sector, and the waste management system, right? But as we all are working in the IT sector, so this is the responsibility of the IT sector also, right? So there is the some very good principles, some rules and regulations, and some best practices of the green IT and the sustainability, which we should apply in our IT sector at organization level, as project level, or maybe at application level, right? So our application should be the environment friendly, and there should not be any adverse effect on our environment because of the IT. So why it is important and why we are talking about the green IT and sustainability? Here are the some points. Lots of energy required for IT systems to work, right? So we are having very high power compute machines, networking devices working, right? A lot of storage devices. We are doing a lot of computations on this data. So very a lot of IT systems are currently working around the globe, right? And these are generating a lot of heat, and cooling is also required, right? So because of it, we need energies, right? And these energy sources might not be the carbon-free energy sources. These might be the traditional energy sources, right? And again, IT accounts for the 17% of the electronic waste in the world, right? So it is the serious concern for the IT. Around 54 million metric tons of e-waste generated till 2019 globally, right? So this is the very huge number. So that's why we are talking about the green IT sustainability. And as a IT professional, it's everyone's responsibility to think about it. Okay, and as per the study recently done by the Michigan University, so about 2% of the global is CO2 emission is because of the IT, right? So we need to think about it. And I am just giving you a very simple scenario here, right? In the late century, we were doing a lot of things in the paper. We are saving our data into the paper, right? Then we move to the paperless because papers are coming from the tree, and that was not a good practice, right? So we adopt a very good idea, and idea was the paperless, and we moved toward storing these data into the storage devices, like, and these storage devices having generations, generation 1, generation 2. We started with the punching cards, then moved to the magnetic tapes. Nowadays we are using HDD, and then now currently using SDD, right? And then the hunger of this data is increasing day by day. We are collecting a lot of data from many sources. Internet of things are here, machine learning is here, right? A lot of data analytics we are doing from many sources. Data is coming to these huge data centers, right? In the around the globe, we are having very big data centers nowadays. These are having very big compute devices, storage devices, networking devices. And once these computer devices are working on the data, right, a lot of algorithm, data analytics algorithm are running, right? So they are also generating heat also. So cooling is also required for it, right? So these energy is coming from the energy sources. these energy sources might be the traditional energy sources, right? Which is not good for the environment. Then another problem is the e-waste, right? But the e-waste we are generating. So as I talked about the generation, so likewise we are having computer generation cells. So right, generation 1 computer, generation 2 computer. So every upcoming generation is and the old generation, right? So as so whatever devices we are using in the old generation, these devices are kind of scraps now, right? So that's why we are increasing day by day these scraps, e-waste, right? And this e-waste management should be there, because the computer devices require, I mean, the manufacturing of these computer devices also using very hazardous materials. Okay, so that is all about why we need the green IT and the sustainability in the IT sector to preserve and to save our environment. So let me go ahead and let me understand the green IT aims. Okay. So it's very simple, reducing the impact of the IT systems to our environment, right? And improve the sustainability to protect our ecosystem. So these are the two main aims. Okay. So whatever we are doing in our IT sector, we should do it like that it should not have any adverse or harmful effect into the environment. Okay. So what are the goals and how we can achieve it, right? So first is the improve the IT systems energy efficiency, right? So means with an example, if you give, right? So instead of having dedicated data centers in which we are running the dedicated servers and dedicated machines for a single tenant, right? We should move towards the multi-tenant. Maybe we can move towards the multi-clouds, the shared environment in which we can energy efficiently can use the full power of the server, full power of the networking device, right? So that is in that way we have to start thinking. Another point is use less dangerous materials, right? So in the manufacturing of the IT devices, we are using very harmful materials like chromium we are using, lead, mercury we are using, right? So the manufacturing should be in that way that we should use that these hazardous material as much minimum as we can. Third is promote recycling the reused devices. Okay, so I mean, as I told, right? So every upcoming generation is so for old generations devices are scraps, right? After coming the new generations. So that's why we should think about it, and instead of wasting these devices, we should think about the recycling and reuse of these devices. Okay, and if waste is required there, okay, then there should be some mechanism of the decomposition, and this decomposition of the devices should not be the harmful for environment. The last one is use renewable energy, carbon-free energy, right? So a lot of initiative already being taken care by the big cloud company like Google, IBM, AWS, right? So they are manufacturing their data centers like it should not have much requirement of the cooling, right? So in that way we are saving a lot of energy, and the energy sources they are promoting is kind of carbon-free energy sources like this solar panel and the windmills. Next is some quotes from the experts. Okay, so because this is a very serious concern, okay, for all the environment, and topic is very much important. Okay, so we must understand what other leaders and experts are thinking about it. I personally like the quotes which is written in the green, right? We are the first generation to feel the setting of climate change, and we are the last generation that can do something about it. Okay, so this was from the Jay Inslee, and I feel it is a very true statement, and it also generates some kind of sense of responsibility in myself as a IT professional. If I am designing a application, my application should not be harmful to the environment. My application should be run into the serverless environment. My application should save the energy, okay, and whatever components my application is having, maybe networking components, storage components, then I should design in that way. It should be maybe the multi-tenant system, right? It should be the shared, it should run in the shared system. logically separated, right? For security, it should be the logical separated. It not require the physical separated system, which is underutilized, right? So whatever IT systems we are using, energy efficiently, we have to use them. Okay. So going ahead, now we will start narrow down our discussions towards the implementation. Okay, from here we will not talk about the manufacturing and the e-based management system of the IT devices. We will discuss about the software lifecycle, and in the software lifecycle how we can implement the green IT and the sustainability. So first point is move to cloud, right? So instead of having dedicated cloud, we should move towards the shared environment. Instead of having single tenant, we should move towards the multi tenant environment. And this is in this way we can very efficiently use, right, our devices, as well as it will be cost saving also. Okay, so this is the other benefit of cost saving, and this is the very huge difference might be for the applications and for the business purpose. Energy efficient runtime environment. Okay, so instead of running your application into the heavy servers, think about to break down applications into the microservices, and we should think about the virtualization if our applications could run into the virtual machines, and mainly the container environment, right? Because this is the very energy efficient way to run applications. And while we are thinking, we should think about the networking, all the components of your application in very energy efficient way, right? So all in all, runtime environment we should think about, and so that our application could run in the energy efficient way. Third and the important point, and we will discuss more on this, okay, is the serverless. Go to serverless. Design application to promote the serverless whenever is possible, right? So our software development is having stages, starting from the design stage, then the development stage, then the build of application stage, and finally the running the application. So we should start thinking about the serverless from the first phase itself, from the design phase itself, that our application should be capable to run in the serverless environment. Okay, and while we are building the application, then this build, right, that CI/CD build, the pipeline should also be kind of the serverless, and the runtime of the application should also be serverless. So here in the left, here are some very useful tools, right? Known for the serverless. In AWS, you know the Fargate, in which we can run our web application as well as backend jobs. IBM Code Engine is also very good example, right? It is the same as Fargate. Uh, we can run web application as well as backend code, right? FaaS, function as a service, you know, Lambda in the AWS, right? And functions in Azure and IBM Cloud and in Google Cloud, right? So this is the completely simple 100% serverless environment to run the backend jobs. Then we for the build of applications, we can use the Travis CI to create the serverless build pipeline. There are some other pipelines also. Cirrus pipeline is there. Okay, AWS code build is there. We can use that functionality, right? So think about the serverless. Our application build should be the serverless. And again, the OpenShift, right, the container environment, a lot of possibilities are here. I am just giving very few examples now. So OpenShift cron jobs, right? If you are having the backend jobs, everyone know that in OpenShift we can run the web applications, right, and other microservices. But for backend jobs also, you can opt the OpenShift and the Kubernetes environment, and by using the cron job functionality there, you can run your backend job, right? So once backend job is required, then a cron will be triggered, then your containers will be ready and move to the node, okay, where it will run the container, and once work is finished, then it will remove the container. In that way, we can save a lot of energy. So let me see some case study now. And before going to case study, let me see why this serverless is so much important. Okay, with a very simple example, I will try to uh, conclude here, right? So suppose in the left hand side, we are having the time, right? And development team is working on a feature, and development team require 3 days time to deploy that feature into the test environment. Okay, and then suppose it's the web application and it's the test web server. So test web server will continuously running, right? If it is a legacy application and we are using some kind of web logic, yeah, web spheres, web server, or maybe something else. So that web server is continuously running, right, with 100% of capacity. It is always in the listening mode for a request. Okay, so once request will come, then it will produce the response, right? So it is always on and always on the listening mode with the 100% of capacity. But as test team is doing nothing, so there is the no traffic in the test server, but still it is running and consuming lot of compute power, okay, and generating heat as well. Once after 3 days, development team will deploy the code into the test server. Then yes, there would be some load because testing has been started, right? But we will say that server is still running in the underutilized way, right? Because maybe test team might be working on the general shift. 6 to 9, so 9 to 6 test team is working, right? So in daytime there might be some traffic, but in the night there would be no traffic, right? So server is running but still not using the complete, right, energy efficiently. It is not running. So what could be if we can move this legacy environment towards the serverless environment? Okay, in that case, if there will be no request, then there will be no instances will be running, right? We are completely 100% saving the energy, 100% saving the cooling, right? So this is the very, and also saving the cost as well for business perspective. So this is the added on example, added on advantage. So no instances are running for these 3 days, and once testing will start the testing after deployment in test, then very minimal instances will be running according to the load. Okay, so because it will be the horizontally scalable system and architecture. So once load will increase, then instances will increase. Otherwise, if load is very minimal, then very minimum number of the instances will be running for that particular time, right? So that is why we require the serverless, and it is the most energy efficient compute power to run our applications. Okay, so that is the takeaway of this slide. So let me move ahead and discuss about the monolithic to serverless. Okay, so how we can do it? Suppose you are having a monolithic applications, then you maybe monolithic application might be written in any kind of language. It might be the web service, it might be the web application. Okay, maybe written in Java, Python, Node.js, anyone. So make change a little bit in your application, okay, so that your application should be run in a container. Okay, once it is done, you can move it into the GitHub, maybe in private repository, and then you can create a DevOps pipeline, automated pipeline here. Okay, CI/CD pipeline, and that CI/CD pipeline you can create with the help of Travis CI, so that pipeline would be the serverless as well. The output of that pipeline would be a container image. That container image you can store in any container registry. In our case, we are storing it into the IBM container registry. From here are now the two scenarios, right? Now your container image is ready, and your application can be run in any environment which is supporting the containers. Okay, container runtimes. It could be the Kubernetes, it could be the OpenShift, it could be the IBM code engine, it could be the Fargate. Okay, so why if we want to go to completely serverless, then either we can mainly for the development and the test environment where we know that load will be very limited for our applications. Okay, and we do not require a dedicated web server to run them. So these kind of things, right, at least for dev and test, we can move it into the completely serverless environment like Fargate or the IBM code engine. Okay, and we can set the minimum instances required is 0. Okay, so in that case, if there is no traffic to our applications, then 0 instances are running. We are completely saving all the server compute powers. Okay, and completely saving the money as well, the cost as well. Okay, And once any request will come to our application, then only the container will be created and it will be moved into the memory of node, and then it will serve the request, and again it will be shut down, right, and will be removed from the memory and runtime. Okay, so that is why this serverless is very much required here. And if in production environment, maybe, right, if application response time and latency should be the minimum, right, and response time should also be very minimum. In that case, we can move our application to either Kubernetes or the OpenShift cluster with the minimum one instances running, and we can set it as the horizontal scalable automatically. So if an request is load will increase, then automatic new instances will be spawn off. Okay, and some kind of application, maybe the production applications, but these applications we know are having very low traffic, productions traffic, and maybe the very low user base. These applications are also a very good candidate to go to the complete serverless where zero instances is running. Okay, so we should leverage the serverless power. Okay, and we should go for the serverless if we are very serious and thinking about our environment. Next is the function as a service. We should identify the backend jobs in our application, in our organizations, and we can move them into the to run as a function as a service, right? So every cloud, this is the example of the IBM cloud, but every cloud is providing this functionality. Okay, the in AWS we have the Lambda, in Google Cloud we have the functions, as well as in Azure and IBM Cloud also. Okay, so we should fine tune our applications and make a little bit change there in our application. So our application backend jobs should be able to run as a function as a service. Okay, and then we can move them. It will again trigger, right, and the functions. There are multiple triggers could be there for the functions, maybe the cron tab trigger, maybe via the some kind of API, right? And then it will run. And at the time of runtime, it can use the on-premises resource as well as the cloud resources as well, right? Like in this example, it is using the IBM Cloud and DB, the email service, and the centralized log service. Okay, so this is how we can move our backend jobs to the completely 100% serverless environment. Serverless DevSecOps implementation, how we can build our pipeline, right? The build pipeline with the serverless. So here is the example. Here is the example of a pipeline. And that pipeline is also doing building the code, deploying the code, and doing the automated testing as well. Okay, so here we are using the Travis CI. So test team will be responsible for writing the test cases, and development team will be responsible for writing the application code. Both teams will be having their own separate Git accounts. Okay, and then we are having the Travis CI. So what Travis CI will do here, suppose my application's requirement for building is like it's required a Linux machine with the Java 11 and Python loaded, right? So we will give this instruction to the Travis CI. Then at that, once the build triggered, okay, then Travis CI will create a virtual machine, a temporary virtual machine for us with the Linux, Java 11, and the Python. Okay, and if we require, suppose Docker also installed, right? So Docker might be there in that virtual machines. Okay, and then you will get the code from the development Git account. You will get the test cases from the test Git account, right? And then your application will be running inside the Docker container of the Travis CI virtual machine. You can do the automated testing, can generate the report, right, test ng reports. You can verify, validate whether your test scenarios pass or fail, and accordingly you can either do the deployment or you can roll back the deployment, right? So all these things can be happen in completely serverless environment, and you can save a lot. So what are the differences here before and after, right? So before there was the higher cost because you are using the dedicated servers. Single point of failures because if a server fails, then your application will stop, your build will stop, right? So this is the single point of failure. Manual support of required, right? You will raise some support tickets, then support team will come and will fix this problem. Server is running all the time, even is no load, right? This is the main concern for the environment. Vertical scale, if we are using the legacy servers, right? So if memory need to be increased, RAM size need to be increased, then it the vertical scalability possibility is only, right? uh, After cost reduction, right? Because suppose this build is required 30 minutes to complete the auto testing and the deployment, right? So my build is running for the 30 minutes also. And if I am using the dedicated build server, it means that dedicated build server is running unnecessary 24 hours, right? But the job is only for 30 minutes. So that's why we will reduce the cost here because we will pay for 30 minutes only. Move from vertical to horizontal scalability, right? So if load will increase, then the automatically new instances will be spawn up. Full auto managed, auto scaled system because it's the service, right? So that's why it is the auto managed system, right? We need not to require any manual support. Availability would be higher, and obviously if there is no load, then no server is there, right? So that is all for related to the green IT and the sustainability in the IT sector, right? As we are the IT professional, so at which level or at which position we are, either maybe the architect, maybe the manager, or maybe the developer, right? So it's our responsibility to whatever we are delivering, we should think about that it should not having any adverse effect on the environment, right? So that is the main concept of the green IT and the sustainability. So there are some certain kind of principles, best practices and rules and regulations which we need to apply the IT sector, and we should all be aware about it. So that's all for this. Thanks everyone for watching.